Hi everyone, it's Mrs. Lauterbach, and I'm here to walk you through your lesson today. I hope you're doing well and life is treating you fair. What we're going to do today is another burning lab, and this has to do a lot with Chapter 3, question and key terms that we're going to fill out here soon. And then what we're going to do is we are going to burn steel wool in the class. Now, if you are working remotely from home, there is an alternative assignment for you, remote online burning steel wool. You'll look at a video of somebody burning steel wool on a link, and then you will then move on to the simulation side in that same doc and understanding how atoms are rearranging during a chemical reaction. So let's start with fill out Chapter 3 question and key terms. So you need to open your Amplify notebook, and we are on slide 19. So in slide 19, it talks about, that if the rust in Westfield's water formed during a chemical reaction between the iron pipes and the fertilizer, then could this chemical reaction have produced other substances as well? Before you can provide the people of Westfield with a complete answer, you'll need to determine what happened to the atoms of substances during a chemical reaction. So our Chapter 3 question is, what was produced during the reaction between the iron pipes and the fertilizer? Was it just rust, or is there another substance in the water? Today we're going to look at key concepts 8 and 9. Key concept 8 is that during a chemical reaction, all of the atoms that make up the reactants rearrange to form the products. And key concept 9 is that during a chemical reaction, atoms cannot be created or destroyed. So what you need to do is you need to pause this video and you need to type in the Chapter 3 question, key concepts inside your own slide. Okay, moving on from that, today you're going to do a lab, and we are going to be burning steel wool. I'll begin the lab by talking about how we'll talk about identifying products and reactants in a chemical equation and understanding the law of conservation of mass. I'll start by burning paper. And when I burn paper in the classroom, I'll measure it before and measure it after. And as we all know, when we burn paper or even wood, we end up having less mass at the end of the reaction. That doesn't necessarily mean that the mass has disappeared or was destroyed. It was just rearranged into a whole new substance. And in the most case, when we talk about like a campfire and we burn the wood, you just smell that smoke. And that's where most of that mass went. It went into a gas, into the smoke itself. So that's what we'll explore in a little bit more detail. But what you're going to focus on is the burning of steel wool. So steel wool, which I happen to bring some right here, is made mostly of iron, which is the same substance that we're looking at in our problem to Westfield. Now, to prevent the steel wool from rusting, they coat it with a light oil, which we know rusting happens naturally between air and water. So the oil just kind of helps slow that process down. It has very little mass, and it won't affect our experiment too greatly. What we're going to do is we're going to heat the steel wool with a 9-volt battery, which will cause an accelerated oxidation or a fast rusting reaction. Okay. Now this is the steel wool right here. I have so many kids that tell me it feels like wool. It's very light and airy, kind of fluffy when I open it up. I like to say you want to tease your wool a little bit, kind of like hair in a sense. Steel wool is used to remove paint, varnish, rust, wax buildup. It's also used to clean motors, heavy machinery, and to tuck into holes and cracks of openings to prevent rodents or birds to enter in. So some fun facts about steel wool. You can buy any of this at the grocery store or hardware store. But what we're going to do in the class is you're going to measure the mass of the steel wool before the reaction, and you're going to measure the mass of the steel wool after the reaction, and you're going to observe what happens, okay? And here, if you're working remotely from home, you're going to click on the link here that says data video, and it will take you to this video right here, and it's a 1.5 minutes, and you can watch the reaction take place. And down below, if you can see, is the mass in grams. And you're going to record the mass at the beginning of the reaction before it's on fire, and at the end of the reaction. Let me see if I can. So here's the mass before, and then you'll get the mass at the end. And then you want to describe what's happening as it's burning in your Google Doc right here. Okay. Later, I have my equation, which is iron is combining with oxygen to perform iron oxide, which we now know is rust. Keep in mind where the reactants are at the beginning of the equation and the products at the end. And you're going to answer the questions, the 4 questions down below. And the last thing I'm going to have you do is go to the chemical reaction simulation activity. And what we're going to do here is we're going to launch the simulation, and it's going to take you to Amplify. You will need to log on with your Google account. And you're going to test 2 types of reactions, and you're going to count the total number of atoms in the reactant side, the product side. Did you see any of the atoms be destroyed, or were they all rearranged? Make sure that when I add my substances, let's see, what was hydrogen and oxygen was the first one. When I do my reaction and I'm testing, I want to pay attention to the atomic scale here, where the atoms are bouncing around and interacting with each other. I also need to pay very close attention to the review page, where I'm looking at the reaction as a whole. I've got my reactants and I've got my products. But the important thing is to make sure I'm on the view atomic scale. And I'm going to count. This is the atoms I'm going to count to make sure I have all of the atoms accounted for and present in the reaction. So this view atomic scale is very, 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 very important. So make sure you're doing that at the end of each reaction in order to complete this assignment. Other than that, I hope you're doing well. I can't wait to see you in class. And it's going to be a great time. Oh, yes, I almost forgot. Please make sure you email me any questions or concerns about your work. The end of the quarter is coming in the next 2 weeks, which means we need to get caught up on any missing assignments or make sure that we're actually mastering and learning the material so that we can get that A on that test, okay? Other than that, have a good day, and I will see you soon.